Hello everyone, my name is Inamullah. I am working in Anjuman Islam Abdul Azim Khatkate Secondary School, Washi. Today we are going to learn similar shapes. Outcome of this topic to understand the principles of similar shapes, especially triangles, and apply these to a range of questions given in our Maharashtra state textbooks. Similarity. Remember, similar shapes are always in proportion to each other. There is no distortion between them. On your screen at the bottom, we have four dolls. If you just look at those four girls, you will find that they looks something similar. But if you observe these four girls carefully, you will find lot of distortion. So each of these four are not similar to each other. So we need to find out similar among these four. Two of them are similar. So whenever we talking about similarity, similarity is consist of those shapes which look same irrespective of their shape, irrespective of their size and dimensions. Two similar objects can be vary in size. One can be smaller than the other one. So always similar shapes will be found in different proportions. But as far as their appearance is concerned, there should not be any distortion. What is mean by that? So we can take an example of a football and tennis ball. Football looks bigger in size. It is bigger in size as compared to tennis ball, but both look same, spherical in shape. So this is best example of similarity, means object which are in proportion, different in size but look same. So similarly you need to observe two dolls out of A, B, C, D which are similar. So here B and D, if you observe these two dolls, they are just differ in terms of their size, but if you see the detailing like their face and other component, you will find that they are similar to each other. We have another four figure A, B, C, D on this screen. A and D in that are similar. They are different in size, but there is no distortion among those two. Screen, all three are right angle triangles where one angle of each triangle is of 90 degree and one angle is of 30 degree. In that case, we can say that the remaining angle in all three triangles is of 60 degree. On the basis of this, I can say that all three triangles on our screen are similar. Their size in proportion, the length of the sides of these three triangles are in different proportion. But as far as their angular measures are concerned, they having same angular measure. Conditions for similarity. Two shapes are similar only when corresponding sides are in proportion and corresponding angles are equal. According to these conditions, we can say that all regular polygons are similar. Conditions for similarity. Two shapes are similar only when corresponding sides are in proportion and corresponding angles are equal. We have three rectangles on our screen. all rectangles are not similar to one another since only condition 2 is true, means their corresponding angles are equal but their corresponding sides are not in proper proportion. Objects are similar, then one is an enlargement of the other. The rectangles below are similar. Find the scale factor of enlargement that maps A to B. Here we have one rectangle which is labeled as A and the other rectangle is B. The length and breadth of rectangle A are 8 centimeter and 5 centimeter. Length and breadth of rectangle B are 16 centimeter and 10 centimeter. We're going to find scale factor. This scale factor is important. Scale factor is actually 2 times. 2 times means you can note that B to A would be uh, half, which means this scale factors is actually tells us what are the difference between one object to other object. For example, length of rectangle A is 8 centimeter. On the other hand, I can say that length of rectangle B is 2 times of length of the rectangle A. In A, length is 8 centimeter. In B, length is 16 centimeter. So we can say it's double. So if you find scale factors of enlargement that maps A to B, so you need to multiply all the sides or the corresponding side of rectangle A by 2 to get the corresponding side of rectangle B. Same way, so if I'll multiply it by 2, I'll get 10 centimeter, which is length of the breadth of the rectangle B. So scale factor is important. You can remember this terminology, scale factor. In next video, we shall refer it as SF in abbreviation. So you need to remember SF stands for scale factor. Now we will see some more examples to find out scale factor of enlargement. Uh, Here again we have two rectangles A and B. 8 rectangle A, length of the rectangle A is 8 centimeter. On the other hand, it is 12 centimeter. And breadth of the rectangle A is 5 centimeter, but it is 7.5 in rectangle B. So we will find out scale factor. So scale factor is 1 into 1 by 2 times of A to get the B. So would be 2 by 3 times. B to A, it is 2 by 3 times. So if you have length of B as 12 centimeter, you can multiply 12 by 2 and divide it by 3, you will get 8. So this is called scale factor. Three rectangles are similar. Find the known side P and Q. So figures are not scale. In rectangle A, its breadth is 2 centimeter, length is 8 centimeter. In rectangle B, length is P, breadth is 24. In rectangle C, length is Q, breadth is 12 and a half. So first thing which we will do is to calculate the scale factor. If we are told that two objects are similar and we can find the scale factor of enlargement by comparing corresponding sides, then we can calculate the value of an unknown side. For example, comparing corresponding side in A and B. So here A and B are two rectangles, first two rectangle. So on comparing scale factor, length of the rectangle A is 8 centimeter and length of the rectangle B is 24 centimeter, and 3 times of 8 will give you 24 centimeter. So here we can say from A to B the scale factor of enlargement from A to B is 3 times of A. So when you multiply 8 by 3 you will get 24. So if breadth of the rectangle is 2 centimeter, so same scale factor will multiply to its breadth to get the corresponding breadth of rectangle B. So in that case, apply the scale factor to find the unknown side. So we're going to apply scale factor is 3 times of A to get the corresponding side in rectangle B. So here P is equals to 3, that is a scale factor, into 2. 2 is the corresponding side in rectangle A, which gives me 6 centimeter. So the value of P or length of P is 6 centimeter. Similar triangle. In our syllabus, we need to apply the property of similarity in similar triangles. So similar triangles are important in mathematics and their application can be used to solve a wide variety of problems. The two conditions for similarity between shapes, as we have seen earlier, are corresponding sides are in proportion and corresponding angles are equal. Two triangles are similar if their corresponding angles are equal. These two triangles are similar since they are equiangular. Why they are equiangular? One set of corresponding side in both the triangle is of 70 degree. One pair of corresponding side in both the triangles is 45 degree. One angle, third angle in first triangle is 65 degree. In second triangle it is also 65 degree because two angles are same as the case in first triangle. So third angle is the remaining angle of the triangle, which should be 65 degree itself. So these two triangles are similar since they are equiangular. If two triangles have two angles the same, then they must be equiangular. For example, 70 plus 45 in second triangle, 70 plus 45 will give you 125, and we know the total angular measure of 70 plus 50 is 125, and we know total angular measure of a triangle is 180 degree. So when you subtract 125 from 180 you will get 55. So this is the remaining angle of the triangle. We have two triangles on our screen. Since the triangle are equiangular, they are similar. So comparing corresponding sides to find the scale factor of enlargement. Scale factor of enlargement from triangle 1 to triangle 2 is 15 upon 12. 15 we're talking about first triangle and second triangle. One of the side in first triangle is of 15 centimeter. while the other corresponding side in another triangle is 12 centimeter. So their ratio will give me 1.25. So this is scale factor of enlargement in these two triangles. So this is scale factor I can use to find the missing side in this triangle. In first triangle the missing side is B, and in second triangle missing side is C. So 1.25 is the scale factor. This scale factor can be used to find out length of B. So 1.25 is a scale factor which is multiplied with 6. 6 is corresponding side in another triangle. The corresponding side of B, which is 6 centimeter in another triangle. So when you multiply 1.25, that is the scale factor with correspond length of corresponding side in other triangle, you will get 7.5 centimeter. So B is 7.5 centimeter. Same way we can calculate C. Again, for C I am calculating. I took 20 upon 1.5. So as you can see, in first case, in order to get the length of B, I am multiplying scale factor with the corresponding side. But in case of C, I am dividing the length of corresponding side with the scale factor. C is equals to 20 upon 1.25. So when you need to calculate corresponding side of smaller triangle, you need to multiply your scale factor with corresponding side. And when you going to find out corresponding side of smaller triangle, you will divide the corresponding side by scale factor. So here we go, since we are calculating C, which is one of the side of smaller triangle, and its corresponding side is another bigger triangle is 20 centimeter. So I'll divide 20 by 1.25. So I'll be getting 16 centimeter. So this way you can find out any side, any corresponding side in two similar triangle if scale factor is known. In order to get the scale factor, you need one pair length of one pair of corresponding side in both the triangles. In our case, it is 15 and 12. So with the help of these two, we get 1.25 as a scale factor. Find unknown side. Again, we have another example. Here we need to find out x and y. Since the triangle are equiangular, they are similar. So comparing corresponding side to find the scale factor of enlargement, I'll take my first triangle, which is where one length is 14 centimeter. In another triangle, the corresponding side is 8 centimeters. So I'll divide 14 by 8 to get my scale factor. My scale factor is 1.75. I can use this scale factor to find the value of x. Here I am multiplying 1.75 with corresponding side in another triangle, because in another triangle, in first triangle, x is the one of the side of greater triangle. So we can multiply scale factor with corresponding side to get the length of x. In order to get the length of y, since y is the length of smaller triangle, so you need to divide corresponding side by scale factor, that is 1.75, to get the length of y. So y is 31.5, that is length of corresponding side in another triangle, divided by scale factor, which is 1.75. So I am getting 18 centimeter. Here we have some more examples. Determine similarity. In triangle ABC and triangle ECD, or DEC, are they similar or not? That we need to identify. So how we can get that? Look, angle ACB and angle ECD, they are vertically opposite angles, so they are equal. Same way, angle ABC is equal with angle DEC since they are alternate angles. Same way, angle BAC and angle EDC are equal. Again, they are alternate angles. So you can say triangle ABC is similar to triangle DEC. We know that the corresponding sides are in proportion. BC is parallel to DE. We have a triangle ABC and the other triangle is ADE. We need to identify whether these two triangles are similar or not. If BC is parallel to DE, this is given condition, which means the line BC is parallel to side DE. So in that case, we can say angle BAC is actually equal with angle DAE because they are common angles in both the triangles. Second important component is angle ABC, which is equal with angle ADE. Both the angles are marked in our figure with red squares. They are equal because they are corresponding angles made by two parallel lines by one transversal AD. Now we have another pair of corresponding angle ACB, which is equal with AED. So these three corresponding angles, pairs of angle, are equal as well congruent to each other. A line drawn parallel to any side of a triangle produces two similar triangles. ADE, ADE, both are same triangle. We can draw BC parallel to AD as the case in figure number 1. So triangle EBC and triangle EAD are similar. Same way, we can make another BC in another triangle. This way, we will have two triangles in second figure. One is triangle DBC and triangle DAE, and both will be similar because a line drawn parallel to any side of the triangle produces two similar triangles. So you need to remember this property. This property will help you to identify two similar triangles made due to a parallel line drawn in a triangle which is parallel to third side of the triangle. We have one example. A tree 5 centimeter high cast a shadow 8 meter long. Find the height of a tree casting shadow 28-meter long. So in this example, our first tree is smaller in size whose height is 5 meter, which casts shadow 8 meter long. We have another tree on our screen which is bigger in size where the height of the tree is labeled as H, which casts shadow 28-meter long on the ground. If I'll join top of both the trees with the end point of the shadow on the ground, it makes two right angle triangle. We need to explain why triangles must be similar. Here, SF is 28 upon 8, that is scaling factor is 28 upon 8, which is one of the corresponding side in both the triangle. So height of the triangle, so this height is one of the side of greater triangle. So we will multiply SF with corresponding side in other triangle. In other triangle it is 5 meter. So you can multiply 3.5 with 5 to get the whole length of bigger tree